Hello, everyone. My name is Yang Wang, and I'm assistant professor in the Department of Chemical, Environmental, and Materials Engineering at the University of Miami. So today I'm happy to share with you all my research about the air we breathe. I would say air and water are the two most important substances that support our human body system. So on average, each adult every day drinks around 1 gallon of water. At the same time, if you consider the volume of air that we inhale into our body system, it's close to 2,000 gallons. And people put a lot of scrutiny about the quality of the water we breathe in. For example, here I'm showing you a water quality report that's generated by the Miami-Dade County. And you can see that this report can be so lengthy that I have to magnify some of the fonts here. So for example, people conduct, or the water station conduct measurement of the bacteria concentration, some disinfectants or byproducts, and then some metals, and then even radioactive contaminants. So luckily, the quality of water satisfies the standard, right? And then I can drink the water safely. But what about the air? So if you check online, and the only agency that's providing the real-time air quality monitoring is the Environmental Protection Agency. And if you find their data, they're only measuring two parameters. And in terms of the air quality, it's giving you an overall good evaluation. But what does good really mean? Is there an excellent above the good, or the good is just a so-so, right? So you may say, well, we live in Miami, in South Florida, the air quality is really good, that we don't need to care about the air quality, right? But even in the cleanest air, there are tiny particles that are invisible to your eyes that can suspend in the air for an almost infinite long time. And many of these particles have very small sizes, maybe tens or hundreds or even thousands thinner than the diameter of your hair or the diameter of the beach sand. And because of their small size, they can suspend in the air for a very long time. And we call these tiny particles as the aerosols. And as a matter of fact, the aerosols play a huge impact on our daily life. If you inhale too many of these aerosols, and especially if these aerosols are toxic, they can lead to respiratory disease and cardiovascular disease. And these aerosols can also act as a carrier that holds the pathogens, for example, the flu virus or SARS-CoV-2 virus, and further transmit the disease. And during the COVID-19 pandemic, especially later on, like in the middle stage or the ending stage, people have confirmed that the SARS-CoV-2 viruses can be transmitted by these tiny aerosols. And that's why the airborne transmission is becoming a more important topic in the prevention and mitigation of this COVID-19 pandemic. And more importantly, air pollution overall is the fourth leading risk factor that leads to the human deaths, even higher than the high body mass index, or significantly higher than the alcohol use. And in addition, if you have too many of these aerosols, they can deteriorate the visibility. An example is the Canadian wildfire earlier this year. And these aerosols are transported to the northeastern United States, and the air quality was really bad for the entire month. And more importantly, these aerosols can play a significant role in our climate. And the goal of my research, or the goal of my group's research, is to try to understand the health and climate impact of these aerosols. For example, during the COVID-19 pandemic, we set up mathematical equations or engineering equations to try to understand among the respiratory droplets, upon evaporation and settling, how many of them can still get suspended in the air and how many of them were settled down onto the ground. So this information can help us generate the policies or understandings regarding the protection or mitigation of the pandemic. We also collaborated with our local hospital when I was in Missouri to try to evaluate the filtration efficiency of the homemade masks. Because we remember at the beginning of the pandemic, there was a severe shortage of these PPEs. So the CDC recommends us to make our homemade masks or DIY masks. So we conduct measurements to confirm or to evaluate the efficiencies of these homemade masks so that we can better protect ourselves. And some of our efforts were actually reported by the New York Times. And more recently, I started to get interested get interested by the e-cigarette aerosols. As we know, e-cigarettes is becoming a trending product, especially among the young adolescents. And according to a recent survey, more than half of the high school kids in the United States report that they were exposed to secondhand e-cigarette aerosols in their past 30 days. So you can see the prevalence of these products among the young adolescents nowadays. And in my group, I sample these aerosols and further do physiochemical characterizations of these aerosols. For example, this study is trying to understand how much heavy metals were contained in these e-cigarette aerosols. And I'm also interested in the climate impact of the aerosols. So sometimes if you happen to look at a satellite image, you will see some of these weird shaped clouds. They have a very long dimension, right? We call these stripy clouds, right? You can call these stripy clouds. They're actually not created by some special winds that elongate the clouds. And these clouds are actually ship tracks. So the tiny aerosols, or let's say the dirty or black tiny particles get suspended in the air. They get floated up in our atmosphere, and the water vapor can condense onto these tiny aerosols and eventually form cloud droplets. And therefore, these clouds are actually just ship tracks. And if you now think of extremes where we emit too much of these aerosols, and all of these aerosols become clouds, right? What's going to happen? Our Earth is actually turning into a snowball, and then it's going to reflect all the radiation back into the universe, and then we may endure our next ice age. So that's why in my group, I'm quite interested in the aerosol, cloud, and climate interactions. We want to understand how these aerosols are being formed in the atmosphere, how they're being evolved, and how they're evolving or getting dispersed in the atmosphere, and how these aerosols form clouds and further influence our climate. And to do these measurements or to improve this understanding, we have to conduct aerosol measurement at the cloud level. And I'm lucky enough to be able to participate in several of these campaigns. So I can hop onto the plane and then turn on my instrument and start to collect the aerosol data. So that's it about my research, and I look forward to the collaboration with all of you. Thank you.